Hi, everyone. Thanks for joining. This office hours is going to be about our latest Isaac ROS release, Isaac ROS 3.0. And we're going to talk about some of the release notes, some of the highlights and exciting new features that are part of this release. I already see about 25, almost 30 people have joined us live. And I hope that today, after talking through some of these highlights, we can also save a lot of time for general Isaac ROS questions. Either some of you have started using Isaac ROS, some of you have not yet. So this is the best place to bring all of your questions from how do I get started, right up to the more like, okay, I'm running so and so Isaac ROS package, but I'm also running into issues. So can you help me? This is the issue I'm facing. So the office hours is meant for all those kind of questions. The questions you can already start posting them in our chat. They don't have to be related to today's topic or to the topic of that session in general. But it can be any Isaac ROS question. And I'll try my best to answer it. For any question that I cannot answer today, or that maybe I need more details to understand your specific hardware and the setup you're running things on, I will direct you to the Isaac ROS forum. I'll also link to that in the slides here. But the Isaac ROS forum would be the next place to post more complex questions, because that's also where you can show us more details and error logs and what is happening on your system. And we can get more insight into it as well. So let's get started with Isaac ROS 3.0, release notes and exciting highlights. Okay, so we host these Isaac ROS office hours every other week, and it's kind of alternating between me and my colleague, Raffaello. So last week, or the week before that, Raffaello spoke about one package in particular, the Isaac ROS April tag package. So fun fact, this is, I think, the first Isaac ROS package, or if not the first, one of the first few. And it is meant for fiducial markers, specifically April tag. What that means is that, say you have a robot navigating in an environment and it needs to figure out where it is. Or say you have a robotic arm that needs to be able to figure out the pose of a certain object or its own pose to be able to grasp the object. So in all of these use cases, one thing that's required is a sort of point of reference for the robot to be able to tell either where it is in the environment based on that unique marker, or for the arm to be able to grasp something based on unique orientation of that marker. And in all of these cases, that marker can be used, like April tag is one such marker that can be used. Some examples of what that looks like is on towards the right of the slide over here. You can put this kind of a fiducial marker anywhere in the environment, and it's sort of a unique point of reference. So that is what April tags are used for. And Isaac ROS April tag is one such package that lets your robot or your robot system communicate and be able to capture information from such April tags. And that is what the last Isaac ROS office hours was all about. So it was about the particular node, how it can be used in a ROS graph, how it is actually accelerated on your hardware based on Nitrous. And Nitrous is something we've covered in a previous Isaac ROS office hour. Nitrous is the hardware acceleration features that enable these Isaac ROS nodes to run optimized on your Jetson or on your NVIDIA GPUs. So I've provided a link and a QR code to that office hours. Go ahead and check it out. And of course, every week we try to cover one separate package or something like today, where we try to cover all the highlights overall. Okay, moving on. Couple of things I wanted to share before we dive into the topic for today. This is the Isaac ROS website. It's the first place you'd go to get started. Just it links you to everything, the documentation, individual webinars or videos that we've done. So this is the place you want to go to also find announcements and more about what's coming in Isaac ROS. This is the thing that I mentioned earlier, the Isaac ROS developer forum. Great place to post all of your questions, and they can be as detailed as you want. You can also attach logs and your launch files and other such things that can help us and our engineers dive more into the problem. It's also just a great place to see what other people are working on using Isaac ROS, and maybe other people have run into issues you're also running into. So you just find a fix very quickly from the developer forum. And this is something we actually look at weekly. So you can expect a fairly quick response on it. And if not, at least we'll ask you for more information and we can kind of work together on this forum. So I'll keep mentioning this throughout the Isaac ROS office hours as well. If there's something I cannot answer in more detail, then this is the place you should be posting the question on. Cool. So going to today's agenda specifically, let's start talking a little bit about generic release notes, and then dive a little more detail into some of the new workflows that we've announced based on Isaac ROS. This is something you may have come across already, called one is Isaac Perceptor, and the second is called Isaac Manipulator. So these are aimed towards specific classes of robots and use cases. We'll be seeing what those are about. And then we'll also be talking about just some more new packages that are maybe used in these reference workflows already, or maybe they're just standalone packages that you can use in your use cases or in your applications. Okay, so let's talk about some general release notes first. So with the new Isaac ROS release, we support all the Jetson Orin platforms. So that includes your Jetson AGX Orin, Orin Nano, Orin NX, and all of them for the latest Jetpack version as well, which is Jetpack 6. So Jetpack 6 introduced a lot of major changes to the Jetpack, or the Jetson OS is something you might think of it as. And Isaac ROS 3.0 supports all of those on Jetpack 6 now. And if you're working not on the Jetson devices, but on an x86 system on your workstation, then that is supported with Ubuntu 22 on CUDA 12.2 only. So that is the versions that you would need to have to make sure that everything runs as expected across your system as well. The next point is that, and this is already, Isaac ROS was already based on ROS 2 Humble. So Humble is that specific version of ROS 2 and continues to be the case. So all Isaac ROS packages work with ROS 2 Humble packages, but that does not mean that they are not compatible with earlier ROS versions as well. So we've tried to keep it as compatible as possible with your system if it's also running, let's say, ROS Noetic. Then we have a sort of bridge. It's called the Isaac ROS Nitrous Bridge. And that is something that lets your ROS Noetic applications communicate with current Isaac ROS based on ROS 2 Humble nodes. So the Isaac ROS Nitrous Bridge is, again, a more detailed topic, not within the scope of today, but we do have some on-demand webinars about it. And also previously have done an Isaac ROS Office Hours that may have touched upon it in a little more detail. So I would encourage you to go, I've linked them towards the end of these slides as well. So I would encourage you to go and check those out for more understanding of what Nitrous is, how it works, what the Nitrous Bridge is, how it helps you communicate with previous ROS versions, and all of that detailed information. But for now, it's important to know that, yes, it supports Humble. Yes, it can work with previous versions of ROS as well. And the next exciting thing is that it's also been tested with Isaac Sim 2023.1.1. So if you're using Isaac Sim or simulation, either to generate your own data or to test models that you've already trained, or you're using it to test maybe a navigation system that you're building, all of that you can do on Isaac Sim, which can also communicate with the Isaac ROS packages. And you can have it sort of running in software in the loop or hardware in the loop kind of a setup. Moving on. Okay, so there are two new ways, or rather two ways now to install an Isaac ROS package. And this is all part of the kind of new and improved documentation. So I'm pretty sure if you guys have already used Isaac ROS before, in the past, before this release, and you open the documentation now, you will see a sort of difference in how each document, tutorial, and quick start for each package is now structured. So one of the first major differences you will notice is earlier there was an install from source option, which is towards the right of the slide over here. And that just meant that once you created your ROS workspace and you created a source folder in that in which you cloned all the relevant package that you wanted to use, you would have to launch the Isaac ROS dev container, right? And in a minute, we'll also talk about all the steps to get to this point where you're installing a package. But so essentially, first you would clone all of them in the source folder. You would launch your Docker container to launch the Isaac ROS dev environment. And then you would actually use the callcon build ROS command. So you would build each package and then you would source it and start running it. So this is, of course, still a way to do it. There is additionally, you will find another way to install all packages, and that is towards the left of the slide here. It's to directly install from the binary or from the Debian. So what that means is that once you've launched your container using the run dev sh script, you can actually just do like a sudo apt-get command and install each package that you're interested in. And you can do a ROS step install for all the dependencies that are needed or the prerequisites for that package. And then you can just start running it. So these are two, maybe like one is slightly quicker, but these are two ways to start installing a package with Isaac ROS. Now, let's talk about some of the steps that you kind of have to do to even get to this point where you're installing a package, right? This is kind of a getting started. Some of you may be familiar, but for those of you who haven't used it before. So the first is setting up your development environment or the container, right? So Isaac ROS, the recommended way to start developing is to use the container simply because it already has all the installations, the dependencies, anything that's any prerequisite that is needed to successfully run all the quick start examples. So it just makes life easier and it's quicker to get started that way. So recommended ways to use the container. Of course, you pull the container image, there's a script. All of this is very well documented. And running the script just spawns that environment for you to start using Isaac ROS and your own packages in as well. So that is the first step. I think it's worth mentioning here that if you're running this on your workstation that has enough storage, that's great. Whereas if you're running it on a smaller Jetson device that maybe has limited like compute and memory, then what you would need to do is install an SSD additionally. Because this container, along with all the ROS bags and kind of the pre-generated, pre-recorded data to run the quick starts, the container can get fairly big. So you need to make sure you have at least like 25 to 30 GBs of memory. So on a Jetson, an SSD may be required. And again, it's all in the documentation how to set that up. So this is probably the first step. Now the second step, once you've, or rather before you even launch the container, is to install sensor dependencies. What that means is that a lot of the quick starts now come with like hawk cameras or real sense cameras, or you can run from Isaac Sim and things like that. So just to make sure that all these options for input are also working correctly, you need to install those dependencies and then you launch the container. Now, the third step would be downloading some of the assets that we spoke about. So assets would basically look like, honestly, just ROS bags. And these ROS bags are intended to get you started as quickly as possible. So once you've downloaded a package, you can kind of start running it based on input from the ROS bag. You don't have to collect your own data or have a physical sensor attached or anything like that. So you need to download all of those initially. Then comes the installation, which is what we talked about on this slide. So installation from these two different ways. Once you've got the package installed and sourced, sourcing command is of course important, then you can actually start running the examples. So you can run all the launch files that already are provided as part of the Isaac ROS documentation. And of course, it also has a lot of parameters that you can tweak to see different behaviors from your node. So all of that API and what parameters are even exposed via the ROS layer, all of that is very well documented. So for any package you're interested in, head on over to the Isaac ROS documentation, go to that specific package, and it will walk you through all these steps that we just talked about, up to when you can actually run the examples. Okay, so let's move on. Again, I'd encourage all of you to start leaving questions in the chat, and we can start answering them one by one. Okay, so this is pretty exciting. This is one of the two new workflows that Isaac ROS has introduced with this release. So the first, this one is called Isaac Perceptor. And this is essentially a workflow for AMRs or autonomous mobile robots in highly unstructured environments. So what I mean by an unstructured environment is just an environment where things are not pre-mapped, where there are maybe moving obstacles that can change, within the hour. And you obviously want your robot to navigate in this environment without collision or without like bumping into stuff, breaking stuff, right? So these kind of unstructured environments is where Isaac Perceptor's use case is the most relevant for all these mobile robots. So it is a camera-based 3D perception system, which means that the attempt is to create a purely visual solution such that you don't need more expensive LiDARs or other sensors also. Of course, for a more robust system, there are still requirements for LiDAR that would give you better performance. But the aim is to eventually get to a point where it can be done visually. Okay. All of this is for autonomous navigation in unstructured environments, like we spoke about. And Isaac Perceptor itself is made out of a bunch of Isaac ROS packages. So that is what it means when I say it's built on top of Isaac ROS. So all the packages that I've listed on this slide here, 5 main ones, we'll talk about them in more detail as well. But it's important to note that these packages are also sort of standalone packages, which means that they can exist independently or outside of Perceptor. So say, for example, you're building your own ROS graph or your own application where you only really have a need for one of these different packages. Yes, you can use it in that way. You do not need to use all of these together, but all of these together form the Perceptor graph. And we'll see what that means very soon on the next slide as well, where there's a big block diagram kind of explaining how all the pieces fit together. But before getting to that, I wanted to talk a little more in detail about each of these packages alone. So let's get started. So the first one is Isaac ROS Nova. This is just a package for time synchronized multi-camera data. Why this is important is that for a lot of navigation applications, when we're talking about autonomous navigation, the robot really needs to be aware of its, like, all the surroundings. It needs to be able to see as much of the environment as it can. And all of that data, of course, cannot be captured by one camera alone, right? So it has to be a combination of 2, 3, 4 cameras. And it also doesn't help if these cameras are out of sync, because then the robot is going to be getting different views of the same environment at different points of time. So that is why synchronization is especially important. And that is what this first package, Isaac ROS Nova, is built for. So first of all, it provides simultaneous start of capture across multiple cameras. Secondly, it integrates with hardware timestamp synchronization on your ORIM platforms. So if you want that kind of high quality sensor fusion from multiple cameras, then the ORIM platforms already provide some hardware timestamps that Isaac ROS Nova uses to synchronize all these different streams. So that is how together it gives the robot or the system the best or most accurate view of the environment at any given time. So Isaac ROS Nova is one of the packages. It has multiple different nodes. I believe it has a data recorder node, it has a data playback node. And another node that I wanted to note here is I think it's called the data validation node or validation node, something like that. This validation node really just checks that the data that has been recorded is good to use. And by that, I just mean that it checks for whether there are any dropped frames or if there has been some desynchronization between the images, or if there is image jitter above a certain acceptable threshold. So all of these things, Isaac ROS Nova gives you the capabilities and the functions to check as well, such that you can be guaranteed that the data you're getting and passing on to the rest of the nodes is time synchronized within an acceptable limit. That's about the first package. The second one, Isaac ROS Visual SLAM. So this package, it might be one of the most popular ones just based on the Isaac ROS forum, because I'm seeing we have a lot of questions. We've had a lot of questions in the past about Visual SLAM. Of course, for more information and more of an in-depth deep dive, I would encourage you to check out the office hours that we had done on this topic. So that would be the right place to get a sort of introduction into what it is. But let me start with a quick recap, what Visual SLAM, what localization and all of this is, right? So for a robot to navigate in an environment, it needs to have very accurate information about where it's located in the environment, because that is how it will compute how to get to a goal state, a goal location, and things like that. So all of that information comes from localization. And Visual SLAM provides that kind of information to your robot. It also provides information on during robot motion, if there is drift in the robot's translation motion or something like that, rotational as well in terms of orientation, then SLAM, which is simultaneous localization and mapping, allows you to correct the path, which means that based on ground truth, if you know the environment has been mapped already and you have that ground truth information, you can figure out where the robot is and correct the path as well. And the mapping part, M, is that it allows you to create a sort of point cloud map of the environment. You can save this map as well. So all of these functionalities are part of the Isaac ROS Visual SLAM package. It's a ROS service wherein you can save that map after you've traversed a certain route within an environment. And you can also load that point cloud map later, and you can actually visualize it. And it's pretty cool. I've done this and I've seen it. You can really see some of the landmark features present in the environment from which you can identify, okay, this is this location in the environment. So that is broadly what Visual SLAM as a task is all about. Isaac ROS Visual SLAM gives you an accelerated way to do this using Nitrous on the NVIDIA GPUs and Jetson devices. And again, this is an attempt to do purely camera-based, just visual odometry and localization and mapping. One change though, one update in this release from the previous Isaac ROS Visual SLAM is that previously it was supported, or all the examples really just talked about using a single stereo camera. Whereas now with this update, it's been upgraded to use multiple different cameras. So you have camera streams coming in from 3 different stereo cameras. You can time sync them using Isaac ROS Nova, create a more detailed map of the environment with a larger field of view. And then all of this can be fed again ahead into the pipeline. But it gives the most accurate localization information for your robot in the environment. So let's see. One of the major reasons multicam kind of had to be introduced is that a common challenge in visual SLAM solutions is, imagine you have just one camera looking straight ahead or looking in some direction. And unfortunately, in that direction, there are no noticeable features in the environment. It could just be a plain white wall or a corridor that has no furniture, no features, or something where there's repeating patterns and it looks almost symmetric. So all of these are very well-known challenges for visual SLAM solutions. And one way of beating those challenges is simply to have different fields of view. And that's, of course, where multi-camera comes into the picture, where it gives you just more angles of view, more perspectives, such that the robot does not get confused or give you wrong localization if it cannot see any features. So Isaac ROS Visual SLAM is based on a library, an accelerated library that was developed at NVIDIA. That library is called cuVSLAM, and cuVSLAM can support up to 16 stereo cameras. It's been tested and can support up to 16. So that's a pretty interesting feature. I believe the tutorial, however, that we've included as part of Isaac ROS Visual SLAM supports up to 3 or maybe 4. So I will have to check that. But then you have all these different tutorials for single hawk camera or multiple hawk camera setup or a single RealSense camera as well. And with IMU fusion, so RealSense with integrated IMU. Also, you have a tutorial for running with Isaac Sim, as I mentioned. So if you don't have an actual camera, but you want to get started and you want to see how this package or any package runs, most tutorials include the Isaac Sim option as well, where you can stream input from like simulated input from Sim and then run all of these graphs and see an output, move the robot around in Isaac Sim as well. Okay, so let's see. There is a question about what is the extrinsic or intrinsic calibration process for multicam with Isaac Nova? Good question. There is, I believe, like this, there's a page in the documentation dedicated to calibration process with Isaac Nova. But also Isaac ROS Nova is based on the Nova sensor suite. So this is again something that maybe was out of scope right now, but if you head on over to the documentation, you can see exactly which cameras and which LiDAR and what are the different sensors included already in this sensor suite. If you buy one of the dev kits that we already have available, all of this is already done for you. So that would include the Nova Orin dev kit or the Carter dev kit. These things are all in the documentation, but these are kind of ready-made setups that you can just use out of the box. And if not, if you're integrating your own, then all the steps on how to calibrate is in the documentation. Thank you. There was another question earlier about, is Perceptor not available on Isaac Sim 4? So as far as I know, some tutorials have been, or I believe all tutorials have been tested and tested to work with the Isaac Sim 2023.1.1. There is going to be minor updates to Isaac ROS as we go as well. Like the 2 to 3.0 jump for Isaac ROS was a major update. But there will be more minor like 3.0.1 or upgrades like that. And I believe with one of them, or with the next few releases of Isaac ROS, the Isaac Sim tutorials will also be updated to use the latest Isaac Sim version. So I think it might be a more like step-by-step update. Maybe not all the tutorial at once will be updated to use Isaac Sim 4, but then you'll see some of them going as the releases go ahead. Okay. Let's see another question here. For those of us who set up with Jetpack 5 and Isaac ROS 2 packages, is there a resource for how best to get upgraded? Okay, awesome. Good question. Yes. So I think the first thing is, if you want to continue, like for whatever reason, if you want to continue using the setup you already have, which is Jetpack 5 with Isaac ROS 2, the previous version, then what you could do is kind of just use the previous version's tag on GitHub. So you just have to make sure when you're cloning the different packages that it's not the latest release, but version, I think 2.1.0 was it, or whatever the previous version was, you would want to give that tag. Then the next question is, if you want to upgrade and you've decided you don't want to use Jetpack 5 anymore, first step would be to follow the Jetson Jetpack documentation and to flash your Jetson with Jetpack 6. So that would be the first step. Second step would be really just to follow the Isaac ROS documentation, because once you have Jetpack 6 set up, you're just going to use the container, the Isaac ROS dev container on top of it. So those are the two main steps for how best. And the resources would be first the Jetpack documentation and then the Isaac ROS documentation. Okay, let's move on. So where were we? We were talking about the Isaac ROS Visual SLAM package. Now let's talk about the third one, part of Perceptor, and this is Isaac ROS Depth Estimation. This is again a package that we've talked about in a previous Isaac ROS Office Hours, and it is mainly to calculate depth between the robot's camera position and potential objects or other obstacles in the environment based on stereo camera disparity. So if you have a stereo camera like RealSense already gives you RGBD images, but if you have, let's say, like a Hawk or some camera where you have two stereo images or a pair, from that, the Isaac ROS depth estimation package can compute a disparity map or a disparity image from which depth can be calculated. So all of this is important to know the depth for navigation, of course, so that you can avoid collision. And also you can generate point clouds based on depth and all that kind of understanding and information about the environment. Now, the Isaac ROS depth estimation package itself includes 3 different nodes or 3 different deep learning models. All of this is learning based, which means that there are pre-trained models from other teams at NVIDIA that the Isaac ROS node respectively uses. So that's those different models are what it's based on. Now, the first is, or rather the main one we'll talk about right now is ESS. So ESS stands for Efficient Semi-Supervised Stereo Depth. I believe that's the full form. And this deep learning network is optimized for RGB stereo cameras. So it might still work with, if you're using non-RGB images, but it's going to be a little less, like the model output or model performance itself won't be that great. So this node, the ESS node, outputs disparity, which can then be used to generate your depth image. And that is, of course, that calculation between disparity and depth is based on your camera's intrinsics. So like the camera focal length and the camera baseline. Once that kind of information is available, it can output depth as well. And then that depth is used further in the pipeline by the other packages for 3D scene reconstruction, which we're going to be talking about very soon. So just if you're curious, there are different versions of ESS as well, the model that I was talking about. One is called ESS, and then there's like a lighter version called light ESS. The only difference really between the two is just a trade-off between performance and resolution. So if your application can afford to be a little slower, but you really need like high resolution images and output, you would want to use ESS. Whereas if you need more, faster performance itself, it's acceptable to go a little lower on the resolution, then you would use light ESS. So all of this, again, more information you can find in the documentation. Or you can also use a combination of these models as well. Okay, let's see. I see another question. It says, when is Z camera officially supported for Isaac ROS 3.0? Previously, it was there for Jetpack 5. Okay, that's right. As far as I'm aware, Stereolab has their SDK for Jetpack 6 released a while back. Right. So I am not aware about the roadmap for kind of re-supporting or bringing back support for the Z cameras I don't know with which Isaac ROS release it's going to happen. You're right that initially it was supported with the Jetpack 5. And then at the time of development, I think Jetpack 6 did not support it, which is why it was not a part of this release. But I guess once I find out about, which minor release we can expect it to be supported with again, we'd probably make a post about it on the Isaac ROS forum. So stay tuned over there. Okay. Right, now let's talk about the fourth package here, which is Isaac ROS NVBlocks. So this is the package for local 3D scene reconstruction and mapping. What local 3D scene reconstruction really means is creating like a very accurate representation of the physical space for navigation, and also it finds use cases in manipulation as well. And what that means is that let's consider an indoor use case where your robot is navigating within a warehouse or like a factory environment. Then if you want to kind of simultaneously, while the robot is navigating, you want to create this sort of a map structure. Look at the image on the slide here. This is what it would look like. You have voxels or these little like 3D cubes forming all the obstacles and objects that the robot is surrounded by. So this kind of a 3D scene reconstruction is exactly what Isaac ROS NVBlocks is used for. What the mapping part here means is that if you kind of see the colored zones in that image, the colored zone represents your distance to a certain object, or it kind of represents whether that particular location is occupied or free for the robot to move in. And that information is very important, as you can imagine, in a navigation use case, where it really needs to know if there's an object or not, and if it's going to collide by moving into that grid or that location of the map or not. This is what mapping is kind of called. And all of this information NVBlocks generates as a cost map. If any of you have used navigation before, cost map is a very fundamental concept of navigation. And a cost map, you can really just imagine it as a grid of the physical space. Each cell of the grid is given some status of whether it's free or occupied. So that's just like a value that indicates free or occupancy status of that cell. And based on which the robot can plan a path either around it or through that cell, or just something from while moving from its current state to a goal location. It has information about which cells it can even cross and which it cannot, because there's an obstacle there. So that grid is called a cost map. And that is something that the Isaac ROS NVBlocks package creates for you. So two things. First is that it creates this cost map. Cost map can be fed into your navigation stack, typically nav2 or something that you may be building. And then that updates in real time whether there's an obstacle or not. And the second thing NVBlocks generates is this 3D mesh of the environment. That is really, it's just good for visualization use case, but it helps you see the environment and understand where your robot is navigating. Now, what NVBlocks uses mainly is depth and camera pose. So that is how the earlier two packages we talked about are relevant. From Visual Slam, you can get the pose of the camera. And from Isaac ROS depth estimation, you can get the actual depth between robot and obstacle. These are the inputs that NVBlocks uses to construct this scene in real time and to generate the cost map as well. And the great thing is that it can map not only static scenes where you already have obstacles that are not moving, but also dynamic scenes where you have, let's say, people, right? People are walking around the factory floor. You want to map them and avoid them as well. So it works with more dynamic objects like people, other robots, moving forklifts and things like that. Now let's talk about, okay, so Isaac ROS NVBlocks is kind of the core of Isaac Perceptor, if you may, because it gives the best capabilities in terms of based on the input, it gives you a very quick real-time cost map and visualization on RBase or Foxglove, whatever you choose to use. Oh yeah, an important point to note here is that this mesh that is generated can be viewed on RBase previously as well, like with previous Isaac ROS releases. But with the new release, it can also be viewed on Foxglove. So you can have, typically you don't run visualization on the robot that's running in the environment, right? You have visualization on another workstation that's maybe closer to you as the controller. So Foxglove is an additional way now that you can visualize on your other workstation as well. Okay, now the final package, Isaac ROS Image Pipeline. This is really, this package has obviously existed for a long time and it's just been updated, with every release. It contains all the nodes that you need for GPU accelerated image processing. The reason why this is important is that a lot of the perception functions that Isaac ROS uses cannot directly just use images as is, right, from the sensors. The images themselves need to go through some certain formatting steps to be able to get it to an appropriate type. So now some of these functions could include cropping or image resizing, correcting for lens distortion, color conversion, right? All of these things can be handled by the various nodes in Isaac ROS image pipeline. And then once you have input that is acceptable to use by your separate perceptions nodes or perception modules, then all these images can be fed accordingly into those. Again, each of these packages we've done office hours previously, and if we haven't, we'll be doing them soon. So feel free to check those out for much more detail about than we could go into today. Okay, so this is just the overall graph, kind of the technical block diagram for Isaac Perceptor. All of the blocks in green are developed by NVIDIA, and the ones in purple are things that you could bring from your own end or use any other ones that you already use in your system. So you'll be familiar with some of these blocks, but let me spend maybe a minute walking through it anyway. Let's see. So you have multiple ways of input coming in from the left. It can be a pre-recorded ROS bag. It can be online live cameras, or it can be like Isaac Sim or simulation. That input goes into your Hawk processing node, which is really just the camera formatting node. And then we see the data moving on to the ESS and ESS Lite models that we talked about. This is important to generate depth images. So if you have a camera already giving RGBD images, you're free to also pass those depth images directly to NVBlocks. All you need to make sure is that NVBlocks gets depth images, RGB images optionally for coloring the mesh, and the camera pose as well. So this camera pose is then coming from the QV SLAM node towards the top of the diagram in green. And once NVBlocks has all of that information, it can start generating your cost map and updating it in real time as well. So that's something that you see going towards the right into the planner, which is nav2, the navigation stack that you can use. And then towards the bottom, it's just your mesh for visualization that goes through like the Foxglove bridge, and then you can view it on Foxglove. So broadly, this is what the diagram would look like. And what you could try doing is based on the nodes that you want to use. Maybe you've developed some of these things yourself, right? Then you can try fitting them in here as well. And all you really need to make sure is that the topic types and service names and like all of those things are mapped to what the other nodes expect. But this is the overall perceptor diagram and how it works. Okay, let's look at the questions. I see a +1 on the Stereo Labs Z update timeline. So yes, let me get back to you about that on the forum. Ooh, interesting question. Okay. Can Isaac Perceptor support Orbeck camera? So I know that Orbeck made like an announcement recently wherein they did integrate some parts with the Perceptor pipeline. So if I can find the link, let me share it on the chat towards the end of the office hours today. But I believe, yes, Isaac Perceptor can support Orbeck camera. Let's see. Okay. This was a little bit about Isaac Perceptor, the first workflow. Now I want to move on to talking about the second new workflow that was based on Isaac ROS. This is called Isaac Manipulator. So the use case here is for robotic arms or manipulators. And typically the tasks that it is expected to do would be picking and placing objects. But Isaac Manipulator is especially useful where in unstructured picking applications. And by unstructured, all it really means is that it does not already know, what kind of objects it's picking up or like where these are located in the environment. So it needs to be able to, that's where the perception part here comes in, that it needs to be able to see and understand its environment and then accordingly pick and place objects based on, how the object is located, oriented, things like that. So Isaac Manipulator is just a set of, again, GPU accelerated packages for industrial robotic arms. It is based on CoMotion. So CoMotion is a library, an accelerated library developed at NVIDIA that allows you to do kind of just trajectory planning when it comes to robotic arms. But we'll also talk about some of the other capabilities that Isaac Manipulator as a whole provides. So now there are multiple, let's take a quick look at the multiple modules that are involved in being able to successfully carry out such a task. Right? So the first would be, say end-to-end, you really just want the robot arm to pick an object from point A and put it at point B. But there are so many things involved here and different modules, right? The first would be object detection, just figuring out where the object is in the environment. Once that is figured out, you need to know the object pose as well, so that the robot gripper knows how to orient itself to grasp the object. With that information, you need to be able to calculate the robot grasp that is needed to successfully do this. And then you need to calculate a path from the robot, the current arm position to the position where it can actually pick up that object. Once that is done, you need to execute that trajectory. This is where CoMotion is helpful. Then you need to execute that grasp successfully, plan another path to point B, and then go and put the object there. So there's a lot of like smaller tasks involved once you actually decompose the whole thing. But the aim of Manipulator is to provide all of those capabilities as far as possible so that you can just chain them together to successfully create or carry forward that entire application of pick and place. So Manipulator provides capabilities not only for path planning in terms of like trajectory planning, but also object detection, pose estimation, motion planning and generation. And all of this, I think needless to say, has to be collision free, right? So what that means is that, let's say like in the GIF here, the robot arm is moving. But if I were to stick my arm in the middle, so like a human hand or arm comes in the way, you don't want the robot arm to hit it. So it's important for it to, in real time, be able to understand that, okay, there is an obstacle here and I need to go around it, or I need to like replan in order to avoid this obstacle. So all of these capabilities are provided as part of Isaac ROS CoMotion and other packages that together form Isaac Manipulator. Now, the beauty is that you do not need, much like in Perceptor, you do not need to use all these packages the way they are written in the documentation, but you can rather, each of them are standalone. So you can really pick up any of the packages that you find use for and use it in your application. And it's very modular in that sense. So the first package part of Isaac Manipulator is, of course, Isaac ROS CoMotion, based on the CoMotion library for collision-free trajectory and motion generation. It requires the URDF, or Unified Robot Format, description format, to describe basic like robot kinematics, and then an XRDF, which is an extended description also with information about collision. So once you've provided these to CoMotion, and of course you calibrate if you have a real robot arm, then you can run like all of these tutorials. One important thing to note here is that the like CoMotion itself contains two ROS nodes. So the first is for the planner node itself for planning the motion. And the second is a robot segmentation node. So why that is needed is, as you can imagine, as the robot is moving, it's possible that the robot motion itself or the robot's body can be considered as an obstacle. And you don't want that happening, right? So the robot segmentation node just helps filter out the parts of the robot from the image, such that like once it's segmented and filter out, you can be guaranteed that there's no like weird sort of contributions from the robot arm itself in while planning depth. So that is about the CoMotion package. Then we have Isaac ROS NV blocks, which we talked about in Perceptor as well. This is for 3D scene reconstruction of obstacles that may be present. So like I mentioned, if my arm is in the scene, NV blocks and stereo depth together, which is the next one on this slide, these two together will be able to detect there is something here, how far it is from the robot arm, and successfully avoid it to give you that collision-free path. So this is kind of, I think, this is the best way to show how all these Isaac ROS packages can be used in different use cases. Like NV blocks and stereo depth, for example, were also like very relevant and used in Perceptor. They're also used here in a different use case for a different type of robot, but to achieve the same goal of like depth information and 3D scene reconstruction. So I think that's the best way to show how all these packages are really modular and flexible and can be used and applied to your use cases. Okay, I see a question. It says, does Isaac ROS image pipeline support H.265 plus decoding? Okay, I will have to check about this. H.264 definitely, H.265 I think so. Where you would want to check this is, I believe, the image pipeline node or the image pipeline package. There's also a compression package, I believe. So that's the right place to check what it supports with this release. But we can also check and get back to it if we have time later today. Okay, so let's move on to the next slide. Okay, these are just some of some more new packages that were introduced with this release, and some of these find use cases in Perceptor or in Manipulator, and if not, they can also just be used as is in your applications. So the first is Isaac ROS Foundation Pose, which is a 6 degrees of freedom object pose estimation package, and also tracking as well for novel objects. What novel objects over here means is that you do not need to fine tune this model or retrain it for objects of interest. Rather, it's a foundation model. So it's already been trained on a whole bunch of different objects, and it can kind of execute like right out of the bat without any, out of the box without any retraining needed for specific objects. So that is the value that Foundation Pose brings over the other pose estimation nodes that were already part of Isaac ROS previously. And the great thing is that it performs really well despite camera motion and blurring due to that. Even if there's like really strong light reflections or just reflective surfaces on some of the objects, it's known to perform well. And sometimes there are objects that really have no features, right? Like kind of like that cylinder that you see in the GIF. So Foundation Pose works pretty reliably and accurately with across all of these different challenging use cases. All it really needs is, I believe, the object image, like an initial detecting bounding box just for the initial few frames, a depth map, and a 3D CAD model. And what's cool is that the 3D CAD model you can actually use your iPhone to do it. And this is, again, something I've tried. It's pretty cool. You just keep the object, and there's an app that you can download on the iPhone. All of this is in the documentation, by the way. You can scan it from different angles, create that 3D model, and then use that down the line with Foundation Pose to start detecting that particular object. So let's see, that is a little bit about the first one, Isaac ROS foundation pose. Moving on to the second one, which is Isaac ROS RT Deter. So DETR stands for, I think, transformer. It's, let me see, real-time detection transformer. Yes, that's what the RT Deter models. It's a very popular class of object detection models. And NVIDIA kind of created another category based on this, on the RT Deter models called Synthetica DETR or Synthetica Deter. And the beauty of that particular model, it's already pre-trained. So again, you can start running it just out of the box. And it's been pre-trained purely on synthetically generated data from Omniverse. So that means you don't need to go through, creating your own data set, because that can be time consuming, expensive. But rather you can synthetically, like, because this has already been trained on a bunch of synthetic data, you can just start using it on to detect your object positions. And you can see it performs fairly well even across different frames in the GIF over there. So let's see. I see one more question. Okay, it says, how can I create a feedback loop in Isaac Sim to ROS workflow? For example, a proportional controller for a differential mobile robot. So I think this question might be more about like software in loop or hardware in loop. And we do have a couple of guides for, like if you look at the documentation, there's some ways to use Isaac Sim with Isaac ROS such that you have packages communicating data, like taking input from Sim, communicating back to that in terms of navigation and stuff. So I'm not too sure if that helps, but I would encourage you to check out what we already have in terms of software in loop, hardware in loop. And then if not, post like the same question or a more detailed question on the forum, and we can look at some real examples where we've done this and share that. Next question, are these packages possible to run on NVIDIA Jetson or in Nano in real time? So I think, I'm not sure if all of them have been tested on for real time on Jetson or in Nano. On the Jetson AGX Orin, yes. On the Orin Nano, I believe, of course, some might run in real time, but I'm not sure there might be, like, for example, foundation pose is known to be, or any pose estimation actually is known to be heavier and like just much slower. So that may not run in real time, but then there are ways to kind of work around that. So for example, the tracking module in Isaac ROS foundation pose helps you do things in real time. So it cuts down a lot on the latencies. So I think there might be some that run in real time on Orin Nano. I'm not sure if all of them do. But for this, all this information about benchmarking and FPS and latency throughput numbers like that, you can find in the performance summary on Isaac ROS documentation. So once you open the documentation site, you'll find like a pane of options on the left. Over there, you want to select performance summary, and you'll get a table giving all information about like which Jetson platform it's been tested on, what was the FPS, which node in isolation, and which node as part of a graph. So it's a really, really big table, but it has all the information that you'd need about this kind of stuff. There's some questions about ROS 3 here, which I'm not sure about. But there's also some discussion going on in the chat, so I'll let that happen. Can we do transfer learning for custom objects with these models? Yes. So what that means is that for custom objects, some of these models, like foundation pose, for example, won't even need to be retrained or anything. You can just use it as is. But if you want, I believe RT Deter might be a part of NVIDIA Tau, I think, which, or maybe not yet, but like that would allow you to kind of retrain it and fine tune it on a specific object class. But what I would encourage is trying it as is on the objects that you're interested in. If you know, it might actually work, and that's great. And if not, then you try thinking about like how you can retrain it if needed. Okay, next question. I want to use Isaac ROS foundation pose if I want to run in my inline manufacturing process. Okay, every time there is new object on the conveyor, do I need to make a CAD model every time? Got the question. Okay, so yes, at least the way it is right now, you need to make a new CAD model every time for a new object. But I think the make CAD model step is highly simplified now. And if you try doing it for one object, you'll see what I mean. You really just have to use this one app on your iPhone, scan the object from different angles. It maybe takes 2 minutes. And that creates like an OBJ file for you. And then the documentation also has some steps on converting from OBJ to USD, I think, which is needed first. Or there are a couple of steps to doing it. But all of them are, first of all, very well documented. And second of all, each step itself is not that time consuming. So to answer your question, yes, you'll need to make a new CAD model every time. But then B, it's all documented and it's fairly fast. So it will not be like a super time consuming process. You can get this up and running fairly quickly with Foundation Pose. Cool. I'm seeing a lot of questions. This is nice. How robust is the perceptor AMR against variation in height level of ground plane? With the previous version I tested with Jetson, Orin struggles to recover when going up and down slopes. Got it. Okay. So I think there were some questions I've seen about just in general, if there is a sloped plane, does Isaac ROS, does Visual SLAM or maybe does NVBlocks account for that? So I think I am not sure about the limits to which we have tested this. But I think in general, there is no like requirement for a ground plane or for a flat plane rather. So without that requirement, I think it would just be a matter really of maybe testing it, tweaking some of the parameters that are exposed, and really just checking if you can get it to run as it is. And if not, then there are some, because the code is already on GitHub, right? So you can kind of go through the code and see if there are changes you can make to like have it work better in your environment. But I don't know about like, I don't know if we have data on like actual, whether we've tested on really inclined slopes or anything and how it has worked then. Okay. There's a question about ROS 3. I'm not sure about like ROS 3. Does ROS 3 here mean the upgraded version of ROS 2, which is robot operating system, and whether it's going to be supported? So I think what's important to know here is Isaac ROS supports, or like this version supports ROS 2 Humble. And I'm not sure if like on the roadmap we have anything to support the next version. Like if that happens, of course, the first place to check would be the forum or even the website. And if I guess it would be like a next ROS 2, like maybe Jazzy or something, then I'm not sure at what point that update is going to be made with which release of Isaac ROS. So a good place to ask would be the forum for this. Okay, follow-up question. I have run Foundation Pose for my custom object. But how can I run it? Okay, glad to hear that. How can I run it for picking object from conveyor in real time? I see. So to answer that question, I would point you to Isaac Manipulator. So that would be the exact package that, or the collection of packages you're looking at for really picking up objects in real time. Of course, assuming you have your ARM set up, Manipulator would be the best place to use all these other packages in conjunction together to successfully carry out tasks like this. Okay, so there's some clarification on Isaac ROS 3.0 is referring to the NVIDIA release, not a new version of ROS. Oh, yes. Okay, let me make that clarification because I think it seems important. Isaac ROS 3.0 is just the latest release of NVIDIA's Isaac ROS collection of packages. It's not like the, it's not the open source new version of ROS or ROS 2, but just how we are naming the Isaac ROS collection, but it's based on ROS 2 Humble. Okay, more clarification in the chat. Thank you for that. We have some more time, so I'm going to quickly cover up the last few packages here. So Isaac ROS SegFormer and Isaac ROS Segment Anything. These are two new nodes that are part of the Isaac ROS image segmentation package. Both are based on, so the first is transformer-based semantic segmentation. And it was developed by NVIDIA. It's part of the DAO toolkit. And the current example includes, I think, segmenting out for people. So it's called the people SemSegFormer or some name like that. And the second one is basically a decoder for the SAM or segment anything model. This is a promptable segmentation system, which means that it does not just segment out objects based on predefined classes, but as the user or as the developer, you can input a prompt in real time. Like I want to segment out a human or a box or something in this image, and the model that's running will do that for you in real time. So this is a zero-shot model, SAM, which means it can generalize to unseen objects as well. You don't need to fine-tune or retrain per object class or instance. But now Isaac ROS includes a decoder for this as well. So these are two new ways you can perform segmentation on images. And I think this package, Isaac ROS Segment Anything, has been tested with like two versions of SAM. So one is like just the whole model SAM, but the issue there is that, of course, it's a big model. So you're going to need more resources, more compute to run it. But it's also been tested with mobile SAM, which is a lesser compute version. Okay, finally, I want to talk about Isaac ROS Jetson. This is a package that we're going to have going to have another office hours on pretty soon. So if you've used Jetson devices before, you know it's important to continuously monitor device status, right? How much power is it using? what fan control is, dynamic fan control required, GPU frequency, Jetpack version maybe. All these things are available to you through the Jetson Stats package. And now it's also part of Isaac ROS, which means you can start, once you're running the Isaac ROS container, you can start this node as well. And it will kind of wrap the output and like all of this information and publish a message with your device status. So it's very useful for just general analysis, monitoring, diagnostics to see if something's wrong in your system. An example use case would be like, let's say you're running some very heavy compute with a high power load, right, on your Jetson. This package can really help you monitor and even dynamically adjust the power requirements. Or it can help you disable some nodes if some nodes are consuming excessive compute or something like that. So it gives you just more control over your platform. And we'll do a more detailed dive into this as well in another office hours. So stay tuned. Okay, I see one question about, does Perceptor only run on the Nova Carter and Nova Orin dev kit? Or can anyone, okay, so to answer that, no, it cannot, like it can run by itself as well. Can anyone run Perceptor on any setup with any number of cameras? Okay, good question. So the Nova Carter and the Nova Orin dev kit really just are intended to make it easier to start running because it's all calibrated and set up for you. But you can run not only Perceptor but also the packages in it on any setup really. And by any setup, of course, the assumption is that it has been, it is the supported setup from the Isaac ROS documentation, be it on the Jetson or on your workstation. As long as it's one of those supported setups, though, in terms of hardware and software, it can run by itself. Yes. Not with any number of cameras. I think we have tested up to a certain limit of cameras. I believe the current tutorial supports up to 3 or 4. I'll have to check. But as long as it's within those limits of the tutorial, it can run on anything. You don't need to, wait for or like buy the Orin dev kit. Okay, I'm seeing another question. It could be great to have Isaac ROS Office Hours every month and do much deeper analysis or experiments. Okay, noted as feedback. Awesome. We do it every month. We do it twice every month. I think we try doing it like every 2 weeks because it's just me and another colleague. We do it like alternating. We could do a much deeper analysis, but I think this forum is more appropriate for like a question answer format. I think if we do a more deeper analysis, then we can't answer as many questions. But that's just something that we were thinking. We could try doing a much deeper analysis, like maybe pick smaller topics and just do maybe demos or more in depth. But those are generally reserved for webinars. So we have some on-demand like technical webinars, topic-wise, and we felt like that is a better way to do it. And these are more just for like an ask me anything kind of thing. Okay, so I think we have time for this one last question. But before ending, I wanted to share just how to get started. You can scan these QR codes or go to the links as well. There's the developer documentation site, the GitHub, where you can find all code for all packages. Best ways to connect with us would be through the Isaac ROS forum, which I've mentioned throughout. Feel free to post your questions, detailed logs, error logs, everything, and we can help you out there. And then the Isaac ROS official website, where you can get all the information about all the different packages. Okay, let's get to the last few questions now. If I want to run foundation pose on AGX Orin Jetpack 6 and UR30 robot, plus Orbec or RealSense cameras, how can I do that? Where can I ask question if I'm in future for how I can run all things in real time? Where you can ask the question is the Isaac ROS developer forum. The question about how you can run all of this together. So some of these things have already been tested, right? Foundation pose on AGX Orin and on Jetpack 6. And on, let's say, the RealSense camera is already a tutorial that exists in the documentation. So that would be step 1, like get started with that. Step 2 would be, I think it supports, there is a tutorial already for the UR5 or UR5E robot arm. So that would be the next step. For this particular robot arm, I think there are still guides and information on how you can calibrate and bring this into the tutorial as well. Of course, there will be more steps that you have to follow there. But as you go through it, the forum would be the right place to ask for help. Let's see. Sorry, I have a question related to Isaac ROS. This is like packages that should be installed or is an operative system for Jetson devices. Okay, good. I like, fundamental question. Isaac ROS is not an operating system for Jetson devices. So despite the name, ROS stands for Robot Operating System, but it's not an OS like Linux or Windows. It is more like a collection of packages that should be installed. And all these packages are for perception on robotics. So all the things that you need for that kind of a system, for maybe navigation or just perception, that is what Isaac ROS brings you. As for operating system for Jetson devices, Jetpack is what you want to be looking at. Jetpack is more than just the OS. It also gives you a lot of components like CUDA, TensorRT, and things on top that you need to run everything on Jetson. So that is what Jetpack is what you're looking for. Okay, so I think we're over time, but thank you all so much for joining. And I hope I was able to answer a majority of your questions. If not, feel free to post on the Isaac ROS forum. And we'll see you probably in the next 2 weeks again. We'll be doing another deep dive on maybe one of the newer packages or something a little more general that gives us more time to just answer all of your questions. So thanks again for joining. Hope you learned something today, and see you soon.